We are going to start working on this key right here. So I hope that your teacher or someone can airplay this for you. Everybody should have this document, and you're going to complete this. Oops. You're going to check your answers, and you're going to turn it in. You're going to please make sure that your note card is great for doing this, doing your test. First, vector addition. Vector addition is simply a number line. So for our first problem, I'm asking you to do 12 centimeters to the right, and I'm going to start here at 0, and we're going to go by, and I told you to number 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 14, 16, 18, 20. And we're going to move, let me switch colors here. We're going to move 12 to the right. And then I'm going to move 4 more to the right. So we've moved 12 centimeters and we've moved 4 centimeters. So the distance the object moves is 16 centimeters and the displacement is 16 centimeters to the right. Don't forget, displacement is a vector and distance is a scalar quantity. So that's our first one. Second, we're again starting at 0, and my 0 went in the wrong spot, so put your 0 wherever you need it. I'm putting my 0 right here. And again, I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. And we're moving 12 to the right. Then now I'm moving this time 4 to the left. 4 centimeters left and 12 centimeters to the right. So my distance will again be 16 centimeters because we add both vectors. And my displacement will be 8 centimeters right. Because my displacement will be my total distance right here, 8 centimeters. This is my displacement, 8 centimeters right. And I think I'm going to have to turn this off, move this up, turn this back on. Next, we have an object. This time we're at 0 again, and we go 12 centimeters to the left. So I'm going to go 10, 12 centimeters to the left. Then I'm going to go 4 centimeters to the right. I know this isn't beautiful. So we have again a total distance of 16 centimeters, and our displacement this time will be 8 centimeters to the left. So here's how we do our vectors, our distance and displacement. Pretty simple. Next, let's talk about speed. As always, no work, no credit, no exceptions. Is speed a vector or scalar quantity? And speed is scalar because it has no direction. Write down the triangle for speed calculations. Speed equals distance divided by time. So I'm also going to write speed equals d over t. D equals s times t. And t equals d over s. Make sure you know how to do those calculations. For our next problem, we're going to find speed. Let me go to this color. We're going to find speed given this is distance and this is time. I'm going to try to blow this up a little bit. So we'll get 12 kilometers. Speed equals 12 kilometers divided by 1.5 hours. 12 divided by 1.5 equals 8 kilometers per hour. And if you just write 8 without the 0, that's perfectly fine. Next, we're solving for distance. And we're given this number, which is speed, and this number, which is time. So distance, if you'll recall, equals speed times time. So we'll take 12 centimeters per hour times 0.40 hours. And this will equal, I believe it's going to be 4.8 centimeters. So again, make sure you know how to do this. Then find time given. So we're asked to find time. Here we're given distance. And here we're given speed. So our time will equal our distance, 1.5 meters, divided by 2.0 meters per year. Our units will be year. I've got 1.5 divided by 2, 0.75, 0.75 year. So there I've solved one problem for each, for speed, find distance, and find time. Okay, next, velocity. And I've got to turn this down, I think, to go to my next page. Where's my next page? There it is. Write down the triangle for velocity. And our triangle for velocity will be velocity equals distance divided by time. Didn't I have something that asked if this was a scalar or a vector quantity? Oh, there it is. Is velocity a scalar or vector quantity? And velocity is, that's why I couldn't see it, because this thing is in my way. Velocity is a vector quantity because it has direction. Velocity has direction. Okay. There. So here's my triangle. Not very nice. I might try to make this bigger and draw it again. So let's go to velocity equals distance over time. And that's a velocity. So now we're asked to first find velocity, find distance or displacement, and find time. Mathematically, we do these the exact same way as we do speed. The only thing that's different is for the vector quantities, we must include a direction. So this is a vector, and this is a vector. So find the velocity. We are told velocity will equal, we are traveling 14 kilometers west in 1.6 hours. That'll be 14 divided by 1.6. That'll be 8.8. I'll round that to 8.8 kilometers per hour west. And if you don't pick the west, since this is velocity, you're wrong. So make sure to pick that. For our second equation, distance equals speed, here's velocity, 19 centimeters per hour. This is my velocity, and here's my time. Times 0.8 hours. And that equals, I did that wrong, clear, 19 times 0.8 will be 15 centimeters, and we're going to be moving north. Which means what we found here is displacement, because it has direction. Last but not least, we have time. Time will equal distance. I'm not getting a different color. 3.25 centimeters divided by 125 centimeters per second. 325 divided by 125 equals 2.6 seconds. And now time is not vector, so you don't have to deal with that. Next, we have acceleration, and we're going to write down the acceleration triangle. Acceleration equals our change in speed over our change in time. What are the two factors that can result in acceleration? And that's change in speed and change in direction. Okay, next, we're going to find acceleration given 60 seconds, that's time, and here is our velocity or speed. Now we started at 0, so my acceleration is just simply going to be 10 meters per second divided by 6 seconds. Don't forget, when you're doing units here, this is the tough one. You need to remember that I'm going to have 1.7 meters per second squared. The units for acceleration are distance divided by time squared. For a second, how long is time? And we are given, here's an acceleration, and here is our speed. So time, looking at our triangle, will equal S, which is 18. I'm going to write this in a different spot. Time will equal 18 meters per second divided by 7 meters per second squared. 18 divided by 7 is 2.6 seconds. Now, ladies and gentlemen, you need to make sure you know how to do every one of these calculations, because then you'll have calculations on your test. So this is important. So I've done this. I know it's not gorgeous, but it's better than a kick in the teeth. So next, we're going to figure out our speed. I'm trying to switch colors here. At the end of 4 seconds, this is our time, and this is my acceleration. Speed will equal acceleration times time, and that will be 8.0 meters per second squared times 4 seconds. And that will be 32 meters per second. Very good. Next, we have 4 graphs, and we're going to do the shape of a distance versus time graph with constant speed. And this is distance, this is time, and that will be a straight line if it's speeding up like this. If it's slowing down, it'll look like this. Slowing down at a constant speed. Next, we have a distance versus time graph with increasing speed. And now this one is one that, I wish I was there to remind you of this, but these graphs are graphs that you have prepared. I'm sitting in a hotel room. Not in a hotel room, in a hotel lobby. And this is with increasing speed. And that is going to be a curved line. I found a site that has really beautiful looking lines that are so much better than mine. So this is speeding up. Which I asked you for. Now, if you're interested, slowing down looks like that. Here's the hard one. Here's speed versus time, and this one is speed versus time. And this is with constant speed, and that will be a flat line. If it's got constant speed, it's not changing. This is the tough one. I've been grading acceleration tests, and a lot of people got that one wrong. Then last but not least, a speed versus time with increasing speed is a straight line. And this would be increasing speed, so this is speeding up. The last thing on here, we're gonna draw a quick little graph here. And we've got somebody who's traveling 4 kilometers north. So I'm gonna go 2, 4, 1, 2, I guess I'll just do 2, 4, and 6, 2, 4, 6. So we're traveling 4 kilometers north, so we're doing this. That's distance in kilometers, and this is the distance in kilometers. And then we're traveling 2, 4, 6. 6 kilometers and 4 kilometers. So our total distance will be 4 plus 6 will be 10 kilometers. Make sure you know how to get that. For the object's displacement, which will be this is our displacement. We will take our displacement using Pythagorean theorem will be the square root of 4 squared plus 6 squared. And that'll be the square root of 16 plus 36. That will be the square root of 52. And don't report things like that. I hate that. So square root of 52. I'm just putting this, and that'll be 7.2 meters. And that would be, if this is north and this is east, this will be northeast. 7.2 meters northeast. Don't forget, if I ask you to do this, you need, for displacement, you need a direction. So I have a nicer key for this at work, but I don't know where I left it, and I realize I didn't put it in the packet for whoever your substitute is, or for the cadet teachers. So I'm gonna try to send this ugly thing off, and you also will have the option to play this. So good luck on your test. Take a few minutes, make sure you're perfectly ready.